Hi everyone. So today we'll explore some of the basics of what GIS is and some examples of GIS in action. So in the previous video lecture, I identified what a map is, the three types of maps, and how it is beneficial in communicating information. So today, what is GIS and is it simply a map? Well, a GIS or a Geographic Information System lets us visualize, question, analyze, and interpret spatial data to understand if there are any relationships, patterns, and trends. So therefore, GIS is far more than just making a pretty map. It's a way of analyzing and understanding data. So it allows us to capture the data. We can store the data on our computer. We can manage the data by moving the filing systems around and altering the data. We can query the data. We can then analyze it. And then we can display the spatial information. And so this is kind of the power of what GIS allows us to do. So a working GIS integrates 5 key components. There's the hardware, your computer, or a server, there's the software, like in our case, we're going to be using ArcGIS Online, that's the software. If you were to do this stuff on a desktop, it would be something called ArcGIS Pro or ArcGIS Map. Then there's the data that you need to do the analysis with. And in this class, we're going to be primarily dealing with health data, non-communicable disease data. People, such as yourselves, to use the GIS, and certain methods, the procedures that you'll use to perform the analysis. So the hardware is the computer, which I just talked about, that we operate the data on. ArcGIS Online uses an online platform where we are accessing servers that are far, far off, probably down in Redlands or somewhere owned by Amazon. So GIS software provides these functions and the tools needed to store, to analyze, and display this geographic information. So key software components are the tools for the input that allow the manipulation of the geographic information. And data is probably possibly the most important component of GIS, and the data that we're going to be using is data that's already provided to us. So we don't have to actually go out and collect data, we don't have to do questionnaires, and so forth. But the data is important. Without the data, we can't do that. Another good source for data is the US Census Bureau. GIS technologies is of limited value without the people, as I mentioned. If there's people who can't use GIS, from just technicians to analysts, having all this data will not be of value. And to make a GIS system work properly requires not only the necessary investment in the hardware, the software, and the data, but also requires knowledge to utilize the GIS technology. And that's the methods, are the procedures followed to answer the questions needed to be resolved. So methods in GIS include how the data will be accessed, stored, managed, processed, analyzed, and finally presented as an output for a particular application. So again, the key thing is just to understand that GIS is comprised of these 5 different areas. So GIS allows us to capture, store, model, and present these complex systems using geographic or spatial data. So how does it do this? Well, GIS allows us to break down a landscape or Earth into multiple layers and see relationships between these layers. So in this image, we can see a representation of these layers as GIS would see the world. By looking at the data, we can kind of tease out possible relationships that might not otherwise be able to see. So for example, here we have the real world, and then the GIS model. We break this apart with aerial imagery. Or if we have elevation data, transportation data, road networks, bus routes, bus stops, address, parcel data. All counties collect parcels information and updating parcels, the actual physical boundary of those parcels, the value of those parcels, person who owns it. Boundaries, there's counties, census tracts, states, water features, and any kind of data that you might collect. So GIS conceptualizes the world as a set of these layers, and the layers uh, are the mechanism that we use to display the GIS data in our GIS software. So each layer has a theme, as I kind of just went through. For example, imagery, elevation, transportation. These are all called themes or layers. So GIS makes it possible then to integrate the data from all these different sources to answer questions. Now, we don't necessarily need all these layers to answer questions. We might only need one or maybe two. So we don't necessarily have to use everything that is going on in the real world for that area. Just like I said earlier in the last lecture, we're not going to represent everything on our map. So spatial data is at the heart of GIS. And spatial data are data that have a spatial component. It means that the data are connected to a place on the Earth through unique geographic coordinates that allow the data to be located in a geographic space. For example, spatial data includes trees, rivers, water bodies, buildings, transportation networks, heart attacks, obesity, crime locations, or air temperature. So in short, any kind of feature that has a location on the Earth's surface or close to it is referenced as a spatial data. So spatial data is anything that can be mapped. For example, I could not map hair color, for example. That doesn't have a spatial component, or the color of your house. But I could map your house because that has a physical geographic coordinate, whether it's your address or latitude and longitude. So non-spatial data is the descriptive of spatial data. For example, in this image, the fire hydrant has a location on the Earth's surface, so it is spatial data. But the non-spatial data component of the fire hydrant can include things like the color, the manufacturer, flow rate, the date of last service, or when it was installed. These components are attributes about the fire hydrant, don't have a spatial component, so they're referred to as non-spatial data. For health data, this non-spatial data could include their race, age, ethnicity, employment, etc. So the power of GIS comes from linking this spatial data with this attribute data or this non-spatial data. So why is the ability to link attribute to spatial data so important? So here we have a table for all Idaho counties by the population per square mile. So this can be very useful information, but it is also difficult to quickly and easily compare densities across the county. But in this map, which shows the population per square mile, we can quickly and easily show where population density is high or low by using GIS. We're able to link the attribute table to the map. So this is kind of the very beginnings of a very basic map. So we can look at population density. Ada County and Canyon County have the highest population density in Idaho, which kind of makes sense. So what can we do with GIS? And there's so many things that GIS can be used from, anywhere from, in this class, health data to Treasure Valley transportation that deals with the bus routes. They use GIS, to the cities, to the Idaho Department of Fish and Game. The list goes on and on and on. It's almost any field you can think of, GIS is used in. So GIS can be used as a tool in both health, in problem-solving, decision-making process, as well as for the visualization of data in spatial environments. Geospatial data can be used to analyze to determine the location of features in relationships to others, where the most and the least of some features exist, the density of features in a given space, what is happening inside of an area of interest, what is happening near some features or phenomena, and finally how a specific area has changed over time and maybe why it's changed over time. So let's take a look here. We have, if we're kind of interested in exploring heart disease and mortality patterns in Colorado, we could use GIS to link a table containing the number of age-adjusted deaths from the map of heart disease in each county to a file that contains the boundaries. So here we can look at age-adjusted death rates for heart disease from 2004 to 2009 per 100,000. And we can quickly see areas where it's very low, indicated by the white, to areas that are very high, that are in the darker purple color. So why might this be of any interest? Well, intervention, what's going on? Are these people in food deserts? Are they eating unhealthy food? Is it related to income? Is it related to ethnicity or race? So it's just kind of, this is a very good map to start asking questions. There aren't any really answers, but it lets us ask some questions. Here we could take the same data and we can look at, does heart disease appear to bear any relationship to urban areas? So we can see the urban areas in red and heart disease death rates. We can look at that. Maybe there is, maybe there isn't. Doesn't seem to be, but it's another question that could be answered. Here, as we talked about earlier with GIS, the different layers. One layer that we have here is the age-adjusted death rate for heart disease, and the other layer that we overlaid it on top of this is urban areas. So we're putting layers on top of layers to answer questions. Also, we can look at here, this is another thematic map, it's a choropleth map. We can look at obesity trends, and here is obesity in 1985, and no data. And notice this, we have only two categories, less than 10% in the light blue, and 10% to 14%. Here we have obesity rates in 2018. Look at all the categories now. We have no less than 20%, all the way up to greater than 35%. So in this period of time, we've added many different categories, which is important to look and compare the maps that you're looking at apples to apples. And we can see these trends. Obesity rates through the south is high. The west coast is lower, so is the portions of the east coast a little lower in yellow. Colorado has the lowest obesity rate. Why is that? It's a good question to start asking why. Why are these places in the south and kind of up through Missouri and Iowa, Kentucky, West Virginia, why do they have obesity rates that are so high? So these maps are great to start asking questions. Here's another thing we can do with GIS. Here's a study, tobacco retail exposure, smoking prevalence, and poverty in Modesto, California. For those of you who are not familiar with Modesto, Modesto is in the Central Valley of California. It is a farming community, largely. It's where a lot of our fruits and vegetables come from. But here we can look in the upper left map, tobacco retail density per 1,000. And we can look, the darker the color, the more retail there are. Then we can look at smoke, the next map down on the left, adult smoking prevalence. So it's kind of interesting. Again, where there's high retail outlets in kind of the southern portion of the county, there seems to be more adult smokers. But it's also interesting, there's some areas that have kind of here not a lot of prevalent smoking and so forth. And then we can look over here, adults below 185% of the federal poverty level. Again, we can see kind of in the lower areas, the southern areas of Modesto County, we can see again have higher rates of poverty, more adults that smoke. So this would be a great idea of using these kind of maps to look at intervention programs. Here's another one, years of potential life lost from stroke in Michigan between 2004 and 2008, using age 65 standardized by county. So what this is saying is, let's just use one value here, 25. So there are 25 years of potential life lost per 100,000 people in these very light blues, all the way up to the high end of 223 years of potential life loss per 100,000 people in the dark areas. So we can see why does stroke, years of potential life loss, higher in some areas than other areas. And the key thing is that we're kind of using age 65, which is standardized. Here's another choropleth map showing colorectal cancer incident rates. This is 2007, and we can see states that have high colorectal cancer incident rates. And we'll look at those and go, well, why are these states higher than other states? Is it due to lack of intervention, so people are not going to the doctor and being screened? Are these people not have insurance, so they can't go and get screened? Are they just not informed that they should be going and getting screened? Do they have a diet that's uh, more inducive of getting colorectal cancer? Do they not exercise? Do they not eat fruits and vegetables, fiber, high red meat? What is it going on? So these are kind of just the beginning kinds of maps that allow us to ask these spatial questions. So once we start asking these questions, then we can kind of dive in deeper and kind of come up with the root cause of why these states might have higher colorectal cancers. So that's a little overview of what GIS is and some basic examples of what you can do with GIS. You can do far, far more analysis and statistical analysis with GIS, but these are just kind of some basic ideas of how GIS might be used. Have a great day.